Welcome to my channel Anand Solve. So today I am going to solve the second question of Biweekly Contest 181. So the question name is compare sums of Bitonic parts. The question says that you are given a Bitonic array nums of length n. Split the array into two parts. First is ascending part from index 0 to the peak element inclusive, and second is descending part from the peak element to index n minus 1 inclusive. The peak element belong to both parts. Return 0 if the sum of the ascending part is greater, 1 if the sum of the descending part is greater, and minus 1 if the both sums are equal. Notes: a Bitonic array is an array that is strictly increasing up to a single peak element and then strictly decreasing. The next point is an array is said to be strictly increasing if the each element is strictly greater than the previous of 1, and the array is said to be strictly decreasing if the each element is strictly smaller than the previous one, if exist. Okay, so the question says, so the question is simple, that we have to bifurcate the complete array into two parts. One is ascending part and other is descending part, and the peak element will be included in both part. Okay, and if the sum of the ascending part is greater, then we will return 0. If it is lesser, then we will return 1. If both are equal, then we will return minus 1. So the idea is simple. We have to first bifurcate the array into two parts, then apply the condition. So for the getting the idea to bifurcate the array into two parts, and we have to find the peak element. So for that we will iteratively check whether the number is increasing and from which point the number starts decreasing. So that particular point will be the peak point, and after identifying that peak point index, we will calculate the sum of both the parts, and after that we will perform the operations according to the condition. Okay, so now let's write the code for this question. So for that we will use a loop for I in range len of nums, and we will check comparatively one by one between two adjacent numbers. So we will initialize from 1 to length of n nums, and I will check if nums of I is greater than, strictly greater than nums of I minus 1, then we are moving forward, and if the condition is true, then we are going to continue this process, and if the condition is false, we will identify the peak element. Peak element would be the current index I, and just I got the peak element, I will break the loop. So this is the identification of the peak element, and after identifying the peak element, I will bifurcate the array into two parts. The first is the left part. So the left part is equal to, or the left part would be the nums from starting to I plus 1. So I is inclusive, and for the right part we will take, or we will split the nums into two half from I to the end of the array, and in this way I will calculate the sum. I have to use the sum of both the parts, so let's directly calculate sum here. Sum of left part and sum of right part, both we have calculated the sum, and as the question says that if the sum of ascending part is greater, so left part is ascending part and right part is descending part. So we will apply the condition if left part means the ascending part sum is greater, it is greater than the right part, then we will return 0, and elif I will check if left part is less than right part, then return 1, and else both are equal, so we will return -1. So let's try to run this. Okay, once verify it. So instead of going till I+1, I have to go from starting to I, and from I-1 to the last of the array. Now try to run it again. Yeah, first answer is 1, second answer is 0, and third answer is -1. Let's submit this. Okay, it is accepted. So we got the second question, and thank you for watching. Bye bye, take care.